Welcome, everyone. I'm really excited to be here today and talk about token exchange in Keycloak and how it basically plays a vital role in securing modern platforms. I think we all know that authentication is one of the core, let's say, principles or foundations in platform security. But when you have large-scale platforms, it may become especially complex. So when you deal with a lot of microservices, external integrations, service-to-service authentication, this is where token exchange somewhere shines in and provides an elegant and powerful solution for at least some of the authentication challenges that we see. And in this talk, I would like to explore how token exchange can secure authentication flows across different, I would say, platform levels. I get to that, what that means in detail later. But I would like to talk about some, let's say, real-world scenarios and best practices along the way. Before I dive into that, just a quick introduction. My name is Sven-Torben. I'm a principal architect working at Conciso, where I have a strong focus on, I would say, system, software, platform architecture in general, and an especially strong focus on identity and access management. So in the recent years, I've worked extensively with Keycloak, built my own custom extensions, which I open sourced, and did a lot of platform architecture related identity and access management, especially over the last year. Today I would like to take you a bit on a journey. And it's the journey of APIxion. It's a fictional but kind of very realistic developer platform, I would call it, where we'll see how APIxion as a platform company kind of solved authentication challenges with Keycloak and using token exchange in particular. So let me introduce you to APIxion. APIxion, as said, is a fictional developer platform designed around principles to provide engineers with seamless access to, let's say, APIs, infrastructure automation, CI/CD tooling. And it serves as a central hub for developers offering, I would say, self-service capabilities, basically. So a general developer platform, as you may know it. As its core, it's built to handle API management, so providing secure access to internal and external APIs. It's around infrastructure as a service, so to enable teams to provision and manage, let's say, Kubernetes clusters, cloud-native resources, things like that. And especially around CI/CD automation, so streamlining deployment workflows for microservices, for example, and applications. So as APIxion scaled, its authentication and authorization needs became more complex, and led them to some, I would say, authentication challenges. So initially, they relied on OAuth 2 for basic authentication, but as the platform evolves, the support for like multi-tenancy architecture, service-to-service communication, third-party integrations, with that, this basic model quickly kind of broke down, right? So with more teams using their platform, security concerns started emerging, and developers kind of needed a way to delegate access securely between services and enforce strict scoping, prevent privilege escalation, for example. And so with that, they had, I would say, these three major challenges I have on the slides here. So there was a lot of misuse about front-end user tokens, so access tokens for front ends, which were passed around the whole platform, which kind of led to over-permissioned tokens. So you had too many permissions in your tokens across the whole platform. There were API keys hard-coded into all kinds of services, especially for external integrations. And APIxion basically did not have a structured way to control how services should authenticate to each other. Especially when preserving user context. So if you wanted to have the user context as well and not just the service identities flying around, that was a major challenge for them. And there was no clear access control between internal services especially. So where service simply forwarding the user token all the time instead of creating proper service-to-service authentication flows. That led them to some, I would say, basic goals they set themselves for their next iteration of the platform. Oh, this isn't working. Right. Okay. Let's do it this way. Where they said, okay, they wanted to use token exchange to become a key solution tackling these challenges I just introduced. So they want to provide a structured mechanism to managing trust relationships between services while ensuring user and systems had only access to what they needed, so nothing more, nothing less. So they wanted to solve or set the goal to have proper internal service-to-service authentication without misusing these user tokens. They wanted to have secure external API access without all these hard-coded credentials and API tokens, keys, and things like that. And they wanted to ensure fine-grained permission control. So where they had some audience-restricted tokens, and what I would like to do is that by the end of the talk, that all of you have a clear and practical approach to implementing these or achieve these kind of goals as APIxion did, and yeah, tell you a bit about secure scalable authentication and how this can especially work with Keycloak. So let's see where OAuth basically falls short, I would say. So don't get me wrong, OAuth is great for user authentication, but it has some limitations when it comes to, I would say, delegation scenarios. So in this example, for example, when a front-end calls a backend service on behalf of the user here, the backend, in this case, for example, a developer portal, needs to make further requests to other services. Let's assume you have a developer portal and want to spin up a Kubernetes cluster, for example. Now, how should this be handled in such a scenario? Somehow, we would like to have this user identity potentially also be available on the other services in the back. So how do we delegate and propagate this user identity information through this whole chain? A common approach we see is that but often in use, you see in practice a lot, is forwarding user access tokens. So basically, let me check, how's this work? Yeah. In such a scenario, a developer in this case authenticates with his front-end client to Keycloak, gets back an access token, passes the access token to the developer portal, and then the developer portal basically uses the same access token and passes it over to another service. That's a very, very common scenario I see in practice a lot. But that also means that this front-end token has a lot of permissions in it, potentially encoded, and passing this all through. Another scenario we often see is using client credential grant in OAuth, which basically boils down to the user authenticates, passes the token to the developer portal, but then the developer portal just creates or uses the client credential grant to create another token, but that basically authenticates the developer portal and not the user anymore. So we basically lose the user information within the token we then passing to the other service. And then there's a third kind of option I see in the wild a lot, which is basically creating some kind of custom delegation mechanism. So this most likely leads to, I would say, inconsistent implementation, security issues. I've never seen anyone doing this on their own in the right way, I would say. So basically, none of these solutions provide a way to delegate user permissions while enforcing these privilege access in a platform. Or in other words, I think that OAuth alone doesn't provide a built-in way to safely delegate user permissions while having a controlled token for backend services. Especially the first approach we see a lot is sometimes called poor man's delegation. And there's kind of a reason for that. If we look at this a bit deeper, you end up with tokens which look like this. So there are a few things in here, for example, audience claims. Very often you end up with audience claims which are very broad. You have a lot of client information in these tokens. For example, in this case, you have a front-end, a portal, some other service. And I've also seen tokens where the audience was even broader. So depending on what you want to call from your front-end. Or if you think about role-based access control, you see all of these clients or audiences also being available in the resource access tokens in Keycloak. So each client has the roles and you get all of this in. But you end up with a very, very, I would say, broad token scope. Yeah, and that's basically an issue because you have an overprivileged token, you have security risks. So, for example, if you think of a backend service, which gets compromised and somebody can steal such a token, can basically authenticate everywhere with a token. So basically, if one service is compromised, you could say nearly your whole platform is kind of compromised. There's no clear security boundary in there. It's also very hard to do identity tracking in a platform. So if you see such a token, you see there's an authorized party, which was the front end initially, but now if some other client forwards this token, it's not the authorized party anymore, that's actually doing the call. It's a bit tricky. And especially when it then comes to auditing, if these tokens get passed around, you cannot really capture the true request origin anymore at all. So that's what you end up with when you do this poor man's delegation mechanism. And at APIxion, that was a major problem, especially in the early days. They realized that forwarding these tokens was not very sustainable. And yeah, these tokens got reused everywhere. Check this button. So how did APIxion basically change this and fixed it? And that's why they introduced token exchange. So let's talk about token exchange a bit, because that's what this talk is about, right? So token exchange is defined in this RFC 8693. And at its core, it basically allows a service to exchange a token for another token, as easy as that. So the service has a token, can call Keycloak with that token and exchange that token for another token. So instead of blindly forwarding user tokens, as we've seen before, with these excessive permissions, token can get exchanged and then basically be rescoped. So you can precisely scope which information you want to have in a token and have some strict separation of concerns. So token exchange Token exchange basically enables, I would say, 3 kind of functionalities: exchanging user tokens for backend service tokens, doing impersonation, so acting on behalf of another user or even on behalf of another service, if policies allow that, so you will want to restrict that potentially, and calling external APIs using what I would call a centrally managed API token. So you don't have to pass these tokens around anymore, API tokens, but you can basically start managing them at a central IDP. Yeah. So overall, token exchange helps us to, I would say, follow least privilege principles or least privilege access. So services just get the permissions they need and are not over-permissioned anymore. So in a very basic scenario, token exchange works like this. An animation in here, yeah. So in the first step, in this case, a developer or a user in general authenticates to Keycloak the way you all will know it, right? So yeah, so you log into Keycloak, you get back an access token, now the front end has an access token. So now the front end would be able to exchange that token in Keycloak. So instead of passing the token it initially had, this one over here, instead of passing that directly to, let's say, the developer portal in this case, it will exchange this token to Keycloak. So it will go to Keycloak's token endpoint. There's a special grant, it's called it's called a token exchange grant. Pass the token to Keycloak, get back another token, and then forward that token to the developer portal. And with that mechanism, we can basically ensure that the information passed in this token does not contain all the access permissions for all of this landscape we have around here, but it's very, I would say, narrow scoped. And then token exchange would even allow us to do that thing again. So the developer portal, instead of simply forwarding that token to the next service, could do the same thing. So it can exchange a token with Keycloak, gets back another scope token, and then can pass that token forward to the next service. That's the whole magic in token exchange on a very abstract level, I would say. But maybe have a look at how this works in Keycloak. Before we do that, I would like to introduce one more thing, which is very crucial from a security perspective before we enable token exchange. And that's what I would say is called restricting full scope for clients. I'm not sure how aware you are on scoping and clients and things like that. But if you, so by default, a client requests a token from Keycloak, it may receive all roles as we've seen before in the token. So you can go to the client configuration, and I think that it's in the client details. Under the mappers, there's a dedicated scope, if I remember correctly. And within there, you can switch this flag, which says full scope allowed. So what does this do? It basically prevents these over-permission tokens, I would say. Instead of having all scopes, all audiences, all roles encoded into the token, it basically switches that off. And now it allows you to define that explicitly, I would say. So you get some options to allow certain roles and basically scope your token independently. That's very crucial because we end up with tokens which look more like this, so which are very narrow scoped. So for example, the audience for the front-end client will just contain the front-end and not the back-end, the developer portal and other stuff of the platform. Same for the role-based access control. You just get encoded the roles into the token that you would allow when you configure this scoping. That's crucial because it's the foundation to actually make the whole token exchange work, at least from my perspective. I mean, technically it will work even if we switch this on, but you will not, you will always end up with these over-permission tokens in the end. So, and then how do you enable token exchange in Keycloak first? So currently it's a technology preview feature. I know it's the Keycloak community or the maintainers are working to get this in a stable state, I would say, or in a, what do you call it? What is that? It's not a preview feature, it's a productive, great feature, whatever. I think currently you have to still enable it. So you just enable the token exchange feature. And what you might want to enable or need to enable additionally is the fine-grained authorization feature, because that would allow you to basically set up policies later on to define which client is allowed to do a token exchange, set up some policies around it. We'll see later how this will work, actually, in the next step. So once you've enabled that, you would want to assign permissions or lay out some policies to define which service is allowed to do token exchange. So if you have a client in Keycloak, for example, let's say the front end wants to exchange a token for the backend service. You would go to Keycloak and you will go to the backend service, which is a bit unintuitive, I think, but basically you look at this from the target of the token exchange. So if the front end wants to exchange a token for the backend, you would go to the backend service, enable the permissions, and then you see a permission down here, which is called token exchange. So basically here. And then you can start adding policies for the token exchange. So in this case, for example, we have a policy down here which is called control plane clients. So within this particular platform, there's what is called a control plane. There's a set of clients in that control plane. And we assign a policy that all clients in this control plane, for example, are allowed to exchange tokens. So the policy in this case would look like this. We have a policy which is bound to client scopes. So within that platform, there exists a client scope. In this case, it's called plane control. So all clients in that platform are marked with this scope, kind of. It's marker scope, if you will. Doesn't have any further functionality. We just define the set of clients which are part of this control plane, like logically. And we then just assign this to this policy to just, basically we say, as I said, each client in that control plane is allowed to exchange tokens. So you can use other policies here, but they somehow have to be, I would say, client related. You cannot do arbitrary things in the policies. I think that's how token exchange just handles it. It basically looks at the client, not really at the user. So how does this work then? Once you have set up such policies, how does a token exchange request actually look like? So we have the token endpoint here. So it's just regular token endpoint you use for other token-related grants as well. And then the client has, in general, a client has to authenticate. So you may do this for public clients, but I would not recommend that, to be honest. So a client would, for example, authenticate, in this case, with a basic authentication with the client ID and the client secret, but could, of course, be MTLS, signed JWTs, or other things. And then you have to specify, when you do the request, a grant type. This is where you would generally have something like password, for example, or whatnot. In this case, it's token exchange. So you explicitly tell you want to do a token exchange. And then you pass this subject token. So that's a token that the client already holds, like an access token, for example. That's the token you want to exchange. So you pass that to Keycloak with this request. And you tell Keycloak that that is an access token. Could also be a refresh token, for example, but you just have to specify it. And then you say, okay, what kind of token do I expect to get back? In that case here, it's also an access token, but you could also ask for a refresh token. And then in the last step, you would define the audience. So basically the client that you want this token to be scoped for. So in our scenario, if the front end wants to call the backend, you would say it's the backend service, whatever the client ID is. And then when you do that request, you get a token back from Keycloak, assuming policies would allow that. And you end up with a token like this. So it's basically a standard token, I would say. There's no special magic in here, but it's scoped a bit different. So for example, in this token, the authorized party now would be the portal. So what I just described was the front end and the back end. So in this case, it's just a portal. It's the one that did the exchange, kind of. And you see that the audience is then just scoped to that client that you want to pass this token to. And then all the access down here, for example, you don't have all the roles encoded in here, just for the target audience. So it's, as I said, it's very narrow scoped. But besides that, it's a standard JWT access token in this case. So a client now would no longer use the initial token that it initially got, but this is the exchange token and forward that to all the other services. And the service that receives this token now can just do standard validation. So as said, there's no magic. You would do the audience check, you would do the expiration and scopes check, whatever you need. Signature validation, of course. Yeah, no magic in that. So that's the basic mechanism, I would say. And then there are different types of token exchange or scenarios you may want to look at. The first one I've basically just discussed is what is called internal to internal token exchange. So assume both of your clients are within the same Keycloak or in the same realm, if you will, configured in the same realm. So both are considered internal clients. And if you do an exchange there, that's called internal to internal. That's kind of what I just already explained. For example, in this scenario, the front end just does a basic login, then exchanges the token with Keycloak, passes the token to the developer portal. The developer portal itself, it's an internal client, so it can do the exchange, and it just goes away. I've just explained it before. So what we basically get here is that we prevent these over-permissions tokens, and that every service in this platform only has the permissions and privileges it needs. Then there are other scenarios. For example, you may want to exchange external tokens to internal tokens. So if you have a client that's not configured in your realm, but it's external, you can even do token exchange for such scenarios. So let's look at this. For example, if you have an external identity provider, or could be another realm in Keycloak, an external service or a user that's using that service authenticates to that external identity provider. And now that external identity provider could call some internal API. Let's say here's a partner API gateway, for example. And then instead of using that token that we get from the external identity provider and passing it around in our whole platform, we kind of have an entry point to our platform where we exchange that external token for an internal one. So the partner API gateway here takes that token, calls Keycloak, says, give me another token for this one, which I can use internally, and for example, scope that for the internal backend. To make this work, you would have to set up some kind of trust relationship between Keycloak and the external identity provider. But that basically works the same way you would do identity provider federation. So you register the identity provider in Keycloak. With this, you build the trust relationship to the other external IDP. And Keycloak then does the magic under the hood, I would say. So basically validates the token it gets from the partner API gateway, checks the signature and everything with the public keys from the external IDP, checks whether the token exchange policies allow that kind of exchange, and then does the exchange if the policies allow it. So you can then kind of translate an external token into the internal world. And of course, there's the other way around. You can do an internal to external token exchange. So for example, so we kind of flipped sides here. If you have a user that is internal, you can log into Keycloak, can interact with an internal backend. And now if this internal backend needs to call an external partner service, for example, then you may not want to kind of forward your internal tokens to the outside world. And to prevent that, you could actually, the internal backend here can also initiate a token exchange with Keycloak and then ask for a token from the external world, kind of from the external identity provider. The way this most likely works is that the user initially logs in basically to Keycloak and the external identity provider, and you kind of have an identity provider federation mechanism. And when the user comes back and gets an external token, Keycloak can store that token from the external identity provider bound to the session or stored globally. And then during this exchange, the user information can be used to exchange that token for exactly the token we used during this login, and then later pass this back to the external identity provider. That's kind of how the mechanism works. So you have options here to kind of protect your internal platform from all of these external tokens and don't have to pass your internal tokens to the outside world and the other way around. Okay, so now how do we use this in platforms? As I said, it's kind of the secret weapon for platforms, right? So we kind of looked at this from kind of an application layer for now, I would say. So, but all of this doesn't really exist in isolations, right? So if you look at the platform, you have a broader platform security model. And there's a general concept in platforms which you call planes. I'm not sure how many of you do platform development or more application development. But within platforms, you generally organize components within your platform services into so-called planes. A general pattern you see is these three planes, like a control plane, a management plane, and a data plane, where the control plane basically has the responsibility to do orchestration, care about global security policies, all kinds of administrative controls, I would say. Then you have the management plane, which most likely handles identities, API gateways, service registries, policy enforcement overall. And you have a data plane where actually, I would say, workloads run, like business critical services that handle customer traffic, for example, if you have a multi-tenant SaaS platform or so. So basically think of this as a kind of layered security model, if you will, where each plane has different responsibilities and requirements on these different levels when it comes to trust. Yeah. For example, let's take Kubernetes as an example. You generally have a control plane where you have clusters running for, I would say, schedulers, for example, API servers, things like that. And in a management plane, you're more on the IAM services where Keycloak runs. You have the API gateways, potentially observability stacks in there. And on the data plane, you would run clusters where you have your actual workloads from your customers running, like, I don't know, databases, for example, storage related things. Depends a bit. So how does token exchange come into play here? It really helps us to enforce proper trust boundaries between these layers. So we don't end up with tokens which you can use in all of these layers, but we can just scope it to a certain layer within, or a certain plane within the platform. Just to give you some examples, more or less real-world examples. So if you look at cloud providers, for example, you have control planes where there's IAM policy enforcement. You have management planes where there are API gateways and service mesh, for example. Data planes with compute and storage. That's very common on cloud providers. But as you see here, for example, the management plane itself can be built in a similar way, right? So a service mesh could consist of a control plane, management plane, and a data plane in itself. So it's kind of, you could build this in a platform even in a hierarchical fashion. So in service mesh, you generally see control planes with Istio pilot, console control services or servers. You have a management plane where there's authentication, service discovery, most likely where you see Keycloak, Spire, and things like that. And on the data plane, you have like sidecar proxies. Envoy, for example. And if you go to enterprise SaaS platforms, you most likely have in a control plane, tenant management, admin APIs. You go to identity federation if you have multi-dependency, often in a management plane, or you see in a data plane, like the tenant-specific applications, I would say. So this is how it's kind of built in most platforms I've seen so far. And what you want to achieve basically is some kind of policies within these platforms where you say, okay, which layer actually trusts which layer and where can I exchange a token from one, or call, basically do a basic API call from one layer to the other. Is that allowed or not? And now token exchange gives you a mechanism where you can say with policies, if I can exchange a token from a component in one platform layer to a component in another layer, I can enforce this on the IAM side, because if my token exchange doesn't allow that, it's basically blocked. And if you play that game in the whole platform, you can establish some kind of rules of trust relationships. What you generally see is, for example, that the control plane can access the management plane. So if you have tenant management services there, it can exchange it to control token for the management token to configure new, let's say, identity providers, Keycloak, for example. If you have a Keycloak in your management plane, your control plane may want to do that. So it wants to set up a new identity provider in Keycloak, for example, for a new tenant, which wants to use to federation or whatever. What's also very common is that the management plane can access the data plane. For example, if you have an API gateway that exchanges a token for a tenant scope token, like think of you have this central entry point, an API gateway to your platform, but you know it's actually a tenant calling this API gateway. You don't want to end up with a token that will be able to actually use whatever for another tenant, right? So you want to scope that to particular that one tenant and make sure that the token exchange works there. Sometimes it's rare, but you also sometimes see it the other way around. In general, you don't want to have your data plane access something in your platform, but sometimes you have to do it for a management plane. For analytics dashboards are often the case I see there, where you most likely have, I would say, read-only kind of tokens, which allow just read-only access to certain components in the management plane. Service registries are very common, for example. And what you most likely will never see is that a data plane accesses your control plane. That would be a bit weird. Generally, you would block that by all policies. So you don't want a microservice from a tenant accessing your control plane and spinning up new Kubernetes clusters. Very unlikely. But this is where token exchange now gives us a mechanism to actually build these trust relationships or segregate the platform into different kinds of layers. So then you can use internal to external token exchange, external to internal, depending on how you set up your platform. So I've seen scenarios where basically there was just one big realm and all the clients are in there, then you have to do it on a per client basis. But if you, for example, have Keycloak realms per control plane, management plane, and data plane, and this is a different realm, then you would end up with internal to external token exchange scenarios and like things like that. Depends a bit on how you structure your platform overall. When you do that, there's one thing you don't want to miss, and that's kind of observability and auditability, logging, and things like that. In general, you would like to trace the origin of the token exchange or investigate an incident that you see. And Keycloak has some mechanisms that kind of support that. The first thing you may know, audit logs in Keycloak, you can switch that basically on, and then you end up with audit logs for user events in that case that look like this. So you have an event type here, which says there was a token exchange happening. The client initiated it, in this case was the front end. It wanted to exchange a token for the backend service over here. It exchanged this token ID. Okay, it did the token exchange. The token was a refresh token. You see the scopes. And in that case, the subject issuer here, so the initial token the front end wanted to exchange came from an external partner, so like from an external identity provider. You get these logs even for token exchange errors, so I really recommend to switch that on so you get an audit log and understand what's happening in your platform, especially for auditability purpose, but also for seeing patterns that you don't expect, for example, like if you have some incidents. And you would also switch on logging. So generally, when there's token exchange error, you get that in your logs, like with a warning, like in the upper case here. You basically get similar information as we've seen before. In this case, but it also gives you a reason why the token exchange didn't work. So in that case, this client is even allowed to do the token exchange. So you want to monitor that for sure, because that may be an incident here, maybe a misconfiguration for sure, but it gives you an indication if that happens too often that there's something weird going on. And what I would also recommend is to switch that on for successful events, like in the lower case. As you can see here, that's on debug level. So you would want to switch that on for that org Keycloak events packages to have debug logging. So you also see the successful cases. And in the end, the new event metrics in the latest Keycloak versions, I think, are a great improvement. Because if you look at this Keycloak user events total, you can even filter them for these token exchange event, and you can then get metrics on the token exchanges. Yeah, you would like to see the error rates, understand which clients do misuse token exchange, where it is successful. Yeah, you just want to monitor that. So you get a feeling, are there clients that misbehave? Is there a potential attack ongoing? Yeah, and what I would always recommend if you use that, I think that's the client ID and the realm you would have to enable as a label for the metrics to really understand which client is acting. Otherwise, you don't see that in the metrics. Yeah. I think that's kind of crucial. So let me sum this up a bit. How did APIxion use token exchange in the end? So they went from front-end user authentication to internal API accesses where they did token exchange. So they use that to exchange and scope tokens accordingly. They used it for internal service-to-service authentication, where they said, okay, services have to exchange tokens to also scope down the tokens. They did that for external API integrations. So whenever an internal API needs to call an external service, they try to establish that with token exchange and don't have hard-coded API tokens for other services. And as said, they also use it for platform segregation, so to structure these different layers within their overall platform. So there are some best practices they figured out on the way. First thing is always enforce fine-grained permissions, so always try to be as strict as possible with the exchange policies. Do not allow these unrestricted tokens to fly around, and be very explicit. Don't put very broad rules and policies out there where you say everyone can do, like we've seen with the control plane. Even that's a bit tricky, you don't want to do that. Disable the full scope for clients. I've showed that. It's very crucial. If you keep that on, you can basically forget about scoping the tokens. It just won't really work. Use audience restrictions wherever you can, so be specific about your target audiences. Yeah, and then basically establish clear trust boundaries within your platform, like these planes. Be explicit about who can exchange with whom. Do monitor and auditing. Do that a lot, I would say. Otherwise, you won't understand what's going on in your platform anymore. Yeah, and limit token exchange availability is one thing. You may not want every client to be able to do token exchange. So if you look at like call hierarchies, for example, there's never a reason that a leaf node in your call hierarchy does a token exchange. It's kind of, why would you want to allow that? So it also gives you a bit of a structure mechanism within your platform. Yeah, so be very explicit about that. Yeah, so token exchange is kind of critical, I would say, for modern platforms. It's a feature you may want to do when your platform grows. It prevents experiments, delegation. It really enforces trust separation. Yeah, and it overall strengthens your microservice API security and external integrations. So you get a way more stronger overall security model within your platform, I would say. So with that, that brings me to the end of this talk. I think we have still more 5 minutes, so I would like to hear your thoughts on this, maybe answer some questions if you have. Yeah, happy to discuss. Otherwise, I will be around the whole day and happy to discuss until the evening, I'd say, or at a beer later at the bar. Yeah. First of all, thanks. Yeah. Just start from the front. Thomas.
Great talk. Just a small notice, the Keycloak team is planning to have standard support for token exchange in Keycloak 26.2 for internal token.
Okay.
Internal exchange for now. Yeah.
Okay, I think I need to repeat this for the recording, right? So Thomas just mentioned that with Keycloak 26.2, right, we get full support for internal to internal token exchange.
Yeah.
That's released when? Like
experimental.
It's experimental? Okay. Okay, but we've already seen major improvements there, and I think there are more to come, right? So, yeah.
My question is kind of related to what has been mentioned previously. Keycloak documentation has a paragraph saying that the token exchange implementation in Keycloak is a loose interpretation of the standard protocols. Some pieces were left off, some others are implemented not exactly the way the specification describes it. So it doesn't exactly inspire confidence when you read something like that in the documentation. And what are your thoughts on that? Because every time we think about using it, we have that uncomfortable feeling that it might come up on some kind of security audit, and someone will point out that it doesn't conform to some kind of specs, and yeah, this might be an issue later on.
So just to repeat this very short, there are some concerns around that Keycloak doesn't really implement token exchange in the way the OIDC token exchange standard would see it, right? And what my feelings around this are, I mean, I always say it is what it is. I think it's quite standard conform. I'm not really sure. I mean, it works in scenarios where I've seen it. I wouldn't doubt that this isn't secure. I mean, it's a pretty good technology feature until now, but I see great improvements there. And to be honest, if you look at other products, what do you know there? How is it implemented there? Is it standard conform there? I don't know. I would just see it from a kind of pragmatic approach. So I'm good in using it, so it's okay for me.
we're all in this together. So.
Yeah, but maybe we can take this later to the maintainer session. Maybe someone can answer some thoughts about that, or have some opinion. I don't know. Yeah, Alex.
The internal to internal token exchange will be then standard conformant with 26.2 gas design. Yeah, we did a great review on what's not standard conformant at the moment, what we can fix, and for the internal to internal, that part at least be a lot better than standard conformant for 26.2.
Okay. So what Alex just mentioned is that it will be standard conform in 26.2 for the internal to internal token exchange. Is that what I got? Just to repeat this for the recording. Yeah. Thanks. Anyone else? Yeah.
Just a quick hint. You said that you suggest to set the logging level for the events to see them, like also the success events. There's actually a more canonical way to do it, because with this magical, it's actually an SPI, the events logging.
Okay.
So you can say SPI events listener JBoss logging success level, and then say info, and then you have it on info level, and you don't need to do
Okay.
configuration.
I didn't know that. That's great. Yeah, good to know.
It's such a skill.
Okay. Let me take the other side. I think there were questions on the other side as well.
My question was into the use case, for example, when we exchange tokens, the user token or the client token to an internal token.
Yeah.
But then, assuming that the token is valid for 10 minutes or 30 minutes, for example, so I'm asking about the challenge on that too much could be token exchange that one, for example, on the bottom level. For every request that comes from the user, or how do you manage the, for example, caching that certain thing that happens that relates to the other token from the client to not have certain things for every request because that could have a latency for serving the client.
Okay, I get that. So the question is about, I would say, latency, and if we do a token exchange for each and every request client, especially if you're quite, I would say, a long chain, right? So of services where you would want to do a token exchange. To me, that's always a bit of a discussion, kind of an architecture discussion, where you have to kind of find a trade-off between what latency is okay for you versus what kind of security level do you want to reach. I mean, sometimes there's a trade-off you have to make. And you can exchange tokens and give them a, I would say, broader audience. So if you always know, for example, that you're passing a token down a particular chain within your call chain, like there's one service called service A, calling service B, calling service C. You may end up in situations where you say, when you do a token exchange where service A calls service B, you may want to encode scopes or access rights, permissions, roles, whatever, audiences. Also for service C, just to get a better, I'd say, performance or reduce the latency. But with that, you kind of make a security trade-off. But then I would say there's no general answer to that question. It's kind of an architecture trade-off you have to make at some point. I mean, if the latency is still fine, I would go with the more secure approach, exchange on every step. If that's not fine for you with the latency, you may have to find or deal with that trade-off. Yeah. Okay, one last question. Yeah.
So to configure the exchange token, it's actually a little bit of work and to manage that. So when would you say makes sense to move from full delegation, from full manual delegation to the exchange token? Because let's say if we have two clients, for me it might make no sense for that, but maybe later, when is the threshold for that?
It's hard to say. I would say the bigger your platform gets, the more you want to enforce certain structures within your overall platform. If you end up with two clients, I would say, I think it's an overhead there. You may not want to use it. Hard to say, to be honest. I would more look at it from a security perspective instead of looking at it from a pure number of clients, for example, perspective. So if you have certain clients where you say you have to ensure a high security level there, you may want to look at this from that perspective and say, okay, if there's a certain part within my overall architect, or let's say platform landscape, you may want to identify these parts and make these more secure potentially and start from that point instead of just making this a decision pure on the number of clients and introduce it everywhere. It needs to be kind of an evolution. So I strongly would recommend to start with the parts where you need to have a higher security level. Yeah. So that would be my recommendation.
Thank you.
Okay, then thank you very much. As said, I will be around if you want to discuss further. Happy to chat. Yeah, otherwise, thank you again.